Here we have an infinite series, and I want to show that this infinite series converges to 3. And so the first thing I want to do is use what's called partial fraction decomposition to decompose the expression 4 over n times n plus 2. So an equivalent expression would be 4 over x times x plus 2. And we can rewrite this as some constant a over x plus some constant b over x plus 2. And to combine these two expressions, we can cross multiply. So it'd be constant a times x plus 2 plus constant b times x. And dividing by the product of x and x plus 2. And so from here we'll get 4 is equal to x plus constant a times x plus 2 plus constant b times x. And this equation here is true for all x. So what we want to do is pick an x such that this factor right here is 0, or an x that will make this 0. So first, let x be negative 2. And so in the place of x, we have negative 2. And this part here we get 0. And here we get negative 2b. And then equal to 4. And so b would be negative 2. And then next, we'll let x be 0, so that this part will be 0. And so this will be 0 and 0. And so here we get 2a is equal to 4, or 8 is equal to 2. So a will be 2, b will be negative 2. And so the expression 4 over x times x plus 2 can be rewritten as 2 over x plus negative 2 over x plus 2, since a is 2 and b is negative 2. And so this is our original series right here. And so the expression 4 over n plus times n plus 2 can be rewritten as 2 over n minus 2 over n plus 2. And so for this series, the sum of the first 5 terms, these are called partial sums. And so the sum of the first 5 terms is 2.38095. The partial sum, or the sum of the first 10 terms, is 2.651515. The sum of the first 100 terms is 2.96059. The sum of the first 1,000 terms is 2.996. The sum of the first 10,000 terms is 2.9996. The sum of the first 100,000 terms is 2.99996. So what these are called partial sums. And so we can see that as n gets larger and larger and larger, the sequence of partial sums is approaching 3. So we can see that this is approaching 3. And now let's write the sum of the first k terms. So here's the first 10 terms. This is the kth term. So in the place of n, we just have k. And the term before the kth term, in the place of n, we have k minus 1. For this term, in the place of n, we have k minus 2, k minus 3, k minus 4, k minus 5, k minus 6, k minus 7, k minus 8. And then we can see that the minus 2/3 and 2/3 here, they were cancelled out. The minus 2/4 and 2/4. Minus 2/5 and 2/5. 2/6 and 2/6. And so the pattern here is we can see that eventually all of these will get cancelled out. And then right here we can see that the 2 over k minus 6 and the 2 over k minus 6. 2 over k minus 5, 2 over k minus 5. Minus 2 over k minus 4 and 2 over k minus 4. 2 over k minus 3, 2 over k minus 3. So eventually what's going to happen is these terms right here will drop out. And of course these will also get dropped out. And so what's left is 2 over 1, 2 over 2, 2 over k plus 1, 2 over k plus 2. So this is the sum of the first k terms. This is our original series, infinite series. Which is the same as the limit of s sub k as k approaches infinity. Recall that this is the sum of the first k terms. If we allow k to run to infinity, then we get the entire infinite series. But here s sub k is 2 over 1, 2 over 2, minus 2 over k plus 1, minus 2 over k plus 2. As k approaches infinity, this term approaches 0, this term approaches 0. So we get 2 over 1 plus 0 plus 0, which is 3. And so we say that the series with 4 over n times n plus 2 converges to 3. And that's the end of the video.